Hi guys, welcome to Learn Electronics Repair and an amplifier module we've definitely seen before. I had this on a video on the channel 3 or 4 months ago, sometime between 3 and 4 months, and I diagnosed this one quite well. The customer said that the horn speaker isn't working but the bass speaker is, so this is out of an amplified speaker active speaker by amp. So that means there was 2 amplifiers on this board, one driving the woofer and one driving the tweeter, and the tweeter or horn is the lower powered one. So that was the actual fault on it. I will link the video under the description of this one, but after looking at data sheets and some probing around, I came to the decision this amplifier chip is faulty. I had a look at all the various voltage conditions on the pins, enable and such like, and it just appears that everything's okay and it doesn't work. It also gets quite warm under the thermal camera as well. So I got to the point where I was going to order one of these, and that was back in February, I think. So I ordered one from AliExpress, and this is the first time ever I've ordered something that didn't turn up. In May, I actually messaged the supplier to say, look, it still isn't here. It should have been here in March. The delivery date estimated was March, and everything I ordered before and afterwards was turning up or turned up already. So I got in touch and I heard nothing. So in the end, I just ordered another one. I ordered it about 2 weeks ago, and 10 days later it arrived. So it's been here for a couple of days now over the weekend. So what we're going to do in this video, we're going to change this chip, and then we're going to see if this works. Now, normally with a chip like this, what we'd probably do is just cut all the legs off and then remove them individually, because it's very easy to rip pads off these sort of PCBs on the top side. But because I'm not 100%, I'm kind of like 95 to 99%, it is faulty. Let's see if we can get it all out in one piece. If we can't, then we will just use the destructive method, or rather destructive for the chip, not for the board, okay? Here's the amplifier chip. This one has a capacitor strapped across it like some sort of afterthought, so we'll just see if we can get this off. Okay. Yeah. There we go. Keep that safe. The thing is actually fitted here. I could take this entire heatsink off, just unbolt these, take the clip off. I may end up doing that, but I'm going to see if I can actually remove just this thing. You know, why do the harder work if you don't have to? That's the theory here, yeah. That's the theory. Let's see how it works out in practice, yeah. Not always the same thing, I assure you. That might do. It's actually not quite the right size. I think that's a hex and this is a star, whatever you call them, but if it's not in too tight, it'll probably get it. Let's have a go. Yeah. Okay. This is the replacement from AliExpress. 3886TF. Brand new Z3886T. And this is in fact a 3886T, so it should be good. As I recall, this was about €4, €4 or €5. I ordered 2 originally on the first order, which never turned up. You never know, they might. So, let's see. Can we unsolder this thing? The problem with doing this is that you'll often not clear the solder properly, and then when you try to take it out, you end up ripping pads off this side of the board, okay? I still stand by the fact the easy way would be to cut all the pins off and then just remove what's left in the holes and cut them off so they're quite long, so you can, you know, get something to grab hold of to pull them out. But let's try it the other way first. So let's get a bit of plastic under here. I don't want to damage this mica washer that's underneath it. You don't want to put holes in that, otherwise you could find out quite dramatically later. Okay, doesn't want to move. It probably doesn't want to bend because the pins are too solid. Let's see. I'll try a bit of flux and braid on one leg, but I suspect I'm going to end up using the vacuum desoldering tool with this. We can have a go though first, so I'll give it a bit of a warm. This will help. Okay. Add some ready to solder. Yeah, I don't think this is going to unsolder easily. Just sinking quite a bit of heat into this. Probably because I can't get the thing away from the heatsink. I can take the heatsink off altogether, that might help. Yeah, I could do it if I undo these. Let's see. Bit of fresh flux. Okay. Again, just warm it a bit and then we'll try the braid. So, let's go. Well, you can see I've managed to remove the solder. I'm actually moving the pin. Yeah, that might be free actually. Ouch, end of the braid was hot. Of course it was. Not free. No, once it cooled down, it resoldered at this end. Thought that might happen. Okay. Yeah, you see how it doesn't want to unsolder at this side. And if you try to take these out and you haven't got them unsoldered, there's a wire which goes through the board. Probably especially on the heavy power tracks if it's a track both sides for extra current, and you don't want to rip those out the board. Okay, let's have one more go at it, but I don't think this will. So you can see I've got it moving, but then it just springs back. Yeah, so that isn't going to work. Let's not mess around with that anymore. We might have more luck with the vacuum desoldering gun. Probably if I use this and hot air at the same time, I might get somewhere. So we'll just resolder the one that I couldn't unsolder. But some fresh solder is going to help with this, okay? This will help. So a bit of fresh solder on there to give it something to suck at. Okay. We'll try the vacuum tool by itself. It fits over the pin. So that has definitely got that one, and we know it's free. Let's continue with this method. I'm gonna just put the cleaning rod through here. I want to keep it clean, so if I unsolder one or two, then we just run the cleaning rod through it. It's not stuck there. There's like a little kink in the cleaning rod. Basically, it's bent a little bit. You see? Okay. Let's go again. So this time I'll try and show you what I'm doing a bit better, if I can. Waggle it around a little bit. That looks clean. I'll test them before trying to remove the chip. Waggle it a little bit. Okay. It's best just to keep this clear before it clogs up. I mean, okay, it takes you a little bit more time, but I'll tell you what, it'll probably save you a lot of time. Actually, again. Yeah. We'll do 3. Okay, so this is making fairly easy work of it. This is the, well, actually mine's a clone, I'll show you later in the video. Pros Kit SSH992, or is it SS992H? I think that's what it is. Okay. Guys, if you're doing repair work on anything more than a fairly casual basis, unless you're doing solely surface mount, then you should really invest in one of these things. I mean, admittedly, I don't use this all the time, you know that, but when I do decide to use it, it's usually for good reason. Actually, that is clear now. It wasn't a kink in this. There was a blockage slightly. Okay, 3 more. Once again. And always remember, guys, when you're finished with it, clean it again. Yeah. Give it a clean before you put it away, okay? It'll be ready for you next time. Now, let's just make sure this is clear. It's a bit important, this, because if one of these isn't desoldered properly, you're going to possibly damage the board. So that's moving. Yeah, you see how he clicked? So that one wasn't free. Now it is. That one is... I think that one is free. Yeah, the whole thing's moving, Luke. Just this one a little bit. Right, now we can see it's free, okay? Remember that step, guys. It matters. And out it comes. So that is that one. As I say, mine is a clone. But honestly, these things are invaluable. Really, guys. If you didn't have the right tool, then as I suggested in the first part of this video, I recommend you actually cut all the legs off. So cut these front ones, these long ones off first, bend them out of the way, and then you can reach to the top of the other ones and cut all them off, and you end up with just the body of the chip and these pins all stuck in the board. Now, if you know the chip is 100% faulty, there's no point in trying to protect the chip anyway. It's duff, yeah. So you're not losing anything. If you're not 100% sure, but you think it's faulty, and you don't have the right desoldering tools, or you see that it's just not working when you're trying to use braid or whatever you have, cut the pins off anyway. You're far better to destroy the chip than to destroy the PCB, okay? You'll save yourself a world of pain later. So in that situation, if you cannot clearly get all the legs free, as I showed you, then don't go down that alley, okay? Just don't go down there, guys. You'll thank me for that later, okay? So we were lucky, we got it out. Let's put the replacement in. This should go easily enough. I'll add a little bit of fresh heatsink compound. I mean, there wasn't a great deal on the previous chip. Maybe that's why it failed. We also have this mica washer. I can feel the edge of it here. So when this is fitted, the tab should be isolated from the actual heatsink. We need to just check that. Let me have a quick look at the... Yeah, this is the screw that held this on. So again, you can see that there's an insulator in here which goes through the hole in the tab. So it stops the bolt from connecting to the tab. So that tab is definitely supposed to be isolated from the heatsink, and make sure when you fitted the new one that it is. Preferably before you solder it, okay? So, bit of thermal compound. Okay, enough. And I should be able to slide this into the board nicely. Yeah, look at that, just go straight in. Get the hole lined up. Not worried about it. A little bit of thermal compound went down the hole, there was already some in there, okay. Now just straighten it up so it's nice and level with the board. Okay. Tight. I mean, this doesn't have to be like the maximum torque. You don't want to puncture this mica washer anyway, just nice and tight so it's, you know, held well against the board. Now let's just make sure it's okay. Just check the meter. See? Meter working. Tab. Here. No connection. And no connection to the bolt either. The bolt's obviously connected to there. So that's fine. Let's solder it in. Okay, I shouldn't need any more flux, there was plenty on there to start off with. Nice chunky tip on the soldering iron, let the solder flow in through the hole. Which, of course, are all nicely intact because of the way we unsoldered it, yeah? You might want to use some thicker solder. This is 0.6mm, it's what I normally use. Probably 1mm would be a bit better. See, I've got some soldered on here. I'll just get rid of that. Okay. Didn't quite get that one. Go again. Okay. There. Yeah, I'm happy with that one. Okay, what next, guys? Clean off the flux, yeah? So, I can't focus it under there, isopropyl alcohol, that stuff, okay? So that looks like it's cleaned off all the flux, but it hasn't. What it's done is it's just spread it out more thinly across that area of the board, so it's dissolved into the isopropyl alcohol and it's now all over the board. So when it dries out, you probably won't see it, but you'll still have the coating of flux all over that area. So make sure to actually clean it off with kitchen roll, get rid of it. Now we need to put this back together and we need to test it. The customer didn't give me the speakers that go to this, just the actual module. But I know I had no high frequency output. This is the speaker output. So initially I'm just going to put this together, connect my scope and have a look. If I have any reason, I'll have to rig some speakers up and attach them to it. But I think we can probably tell just by using the scope if this is now working. While I'm here, I noticed from a previous repair, more flux, so let's clean this up as well. That isn't my previous repair, by the way, guys. And I think I spotted a bit here as well in this area. Okay, right. Okay, so on this amplifier, and this is not always the case, we have earth, which is the yellow and green, and it also goes to ground, which is this black lead. So that's our reference point, okay, for our scope. We're going to connect the scope to this. So we can use the heatsink. Then we have the two speaker outputs. So that end of this speaker goes to ground, that doesn't, that does, that doesn't. So we can measure on this pin, and one should be the bass and one should be the treble. What I haven't done is connected this capacitor back on, so let's just do that. Okay, and there it is. Right, let's try it. So I've connected the current limiting light bulb. It's up there, ready to go. So that should come on maybe bright as the capacitor's charged and then go dim, basically go out normally. Let's see. Light comes on and it stays on fairly dim. I've got a power light. I've also got a protection light on as well, and that isn't right. That's not right at all. Oh, keyboard fell off top of my power supply where I keep it when I'm not using it. Okay, so that isn't right. Something on here is drawing. Well, the light bulb is maybe a third brightness. It's a 65 watt bulb, so maybe 20 watts or something. And when it's quiescent like this, it shouldn't really. Where's that coming from? Well, we have two power supply rails here. So this black is the common 0 volts on all of them. And then this is one power supply, plus and minus with reference to the black. And that's the other one, plus or minus with reference to the black. And it tells us on the transformer what the actual voltage and currents are. But I've actually just referred back to my previous video on this. And I can say I had, with reference to ground, about plus and minus 70 on one of the bridge rectifiers and plus and minus 35 on the other. Now, with the light bulb on, obviously it's limiting the current through the transformer. So it's limiting those voltages. But I'm interested just to see if one of them is missing, like there's a short or something on one of the rails. I mean, all I've really done is, well, you know what I've done, you've seen what I've done today, yeah? Let's have a quick look. So I'll just get rid of that camera. We don't need that one at the moment. So volts DC. Ground is here. That's the black wire from the transformer. So we'll switch it on again. Let's have a just see what we've got. So again, the light bulb, you can't see it now, but it's done the same thing. So 15, well, a bit below 14 actually, 14.3 on those two. And this one, 31 and 31. So they're about half of what they should be. That suggests that this is dissipating about the same wattage as the light bulb is dissipating, about 30 watts, and it shouldn't be doing that. Last time I had this, and we can just refer to the previous video a moment, which is here. So we can say, I'll just take my voice off there, only hear me once, okay? This is where I was measuring those supply rails I've just checked on. So from ground, what did I have? Yeah, 35. So I've got 15 on this one. 35. So basically what I said, they're about half of what they should be. And this one, 76. Okay. And 76. So we can see that is what I've just confirmed, it all low. The other thing I did on the previous video was take the thermal camera. So I was looking at the chip, the one I've just changed, which is here. Okay, and we can see that that is getting plenty hot. Just let the video run a little bit more. Yeah, there. Okay. There. So that was getting hot. And that was another reason why I thought the chip was faulty, apart from the fact the supply rails were there, the signal was there, it wasn't muted, etc. It wasn't working, okay? So that's what we actually have. Let's have a look to see if our chip is still getting hot. Oh, and there's something getting hot here as well underneath. Let's just go. I didn't really spot this previously. Let me just pause the video. Right. So something there is also hot as well. Okay. There and a bit here, but something there independently is hot and this is hot. Let's have a look. I don't want to take the current limiter out because whatever is drawing the power will probably, well, it will draw more power than it is doing anyway, because obviously the voltage will try to come up then. That's not what we really want to happen. Likelihood of damaging something is high. So different thermal cam I'm using at the moment. I do still have the other one. It just saves me messing around plugging it into the phone. Okay. The chip, the one which I've changed. Let me see if I can get this into an angle where it's a bit easier to see. It's down here, and at the moment obviously it's cold. You can see the actual bolt going through it there, so the chip is kind of here. Okay, let's switch this on again. Okay, so the light bulb's doing what it was doing. What's my chip doing? Well, it's cold. Okay, so that chip is cold now, not warming up at all. So that isn't what's drawing the power. Oh, but do I still have, as I was saying, I had something else there. Okay, that's getting hot, but there's nothing here. So there's something getting hot there. It must be on the other side of the board. Let's just have a look. Okay, so down here we have 3 chips. Power it up again. Okay, let's have a look. Right, so that one is 45 degrees, 46, and this one, just getting the shot a little bit better. Okay, there. I think that's the, yeah, 46, 47, 48. Okay. The other one. Just get the cursor onto it. There we go. 49, 50. So there's something wrong there. 51. Okay, I've seen enough. So what are these things? 2060 JRC. The middle one wasn't getting hot. It was those 2. Okay. They are probably quad op amps. I mean, JRC made or make a lot of audio equipment op amps, usually dual op amps. Let's have a look at the data sheet for those. JRC, NJM 2060, Japanese Radio, or Japan Radio Corporation, I think, or company. This is a quad op amp, is what I thought it was. This is standard sort of layout. So outputs on 1 and 14, 7 and 8, power on 4 and 11, plus supply on 4, minus supply on the 11. We can see it there. Oh, New Japan Radio Company. Yeah, that's maybe what the NJ thing actually stood for then. Comment? Yeah. But the main interesting thing to us is why I was getting hot. Yeah, why are they getting hot? I mean, the only reasons I can think that an op amp would get hot are kind of threefold. 1, that it's faulty. 2, that there's something seriously wrong with the power supply rails. Or 3, that there's short on one or more of the outputs. Really, that's about it. Let's see if we can come to any conclusion on that. So, without having to power it back up first, diode mode, do we have any shorts to ground on the outputs? I'll just get a connection to ground. Let's have a look. So, no. 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 Okay. Let's look on the other one. So I don't see any. Oh, something was connecting to ground. Maybe I just took something. Oh, It's not going to ground. That's the negative supply with a positive on it, okay? So no short to ground. Short to supply rail? Possibly. Well, supply rail is one of them is here. Okay. No. No. No, just reading like diodes. Okay, and then the other supply rail is over here. I'll put the positive on it, it's a negative supply. Should see diodes again. Okay. Well, that reads different to the other ones, but no short. That reads different to the other one. Some of them read a bit different. Okay. So the other option then is we'll just check for protection diodes on these chips basically. So like we were doing before with the red to the, what's this, pin 4. Just check. Pin 4 is a positive supply. So I want to go to black on the pin 4. Okay. And then let's see if we can see the protection diodes on the various op amps. So should read basically the same as each other. Well, that reads open. That reads like a diode. That reads like a diode, maybe a different voltage. 657. It's the same actually. Okay, let's go on this one. So from here is one of the inputs. That also reads open. I'd expect to see a diode junction there, like that one. Yeah, I mean, I don't know how these chips are going to read. How's this one? Try the two inputs. Well, that doesn't see the diode. That doesn't see it either. So some do and some don't. How about this chip? So that sees one. That sees one. That doesn't, rather like this one. Okay, then the other side. That sees a diode junction. That sees a diode junction, but different reading. That doesn't see one. That doesn't either. Compare this pin. See, that one's reading 2 volts compared to on the same pin on the other chip is reading 0.657. So that's not consistent. I'd expect them to be consistent. I'd expect to see diode junctions on all of them. What about these ones up here? So that's one of the outputs. Okay, that reads open. Does that read the same as that one? No, that reads like a resistance, a strange one. Okay, that reads like a rather unusual reading. Similar to that one. And then down this side. That reads like open, like a diode. Like a diode. Remind myself like a diode. Like a diode. Open. I can't come to any particularly conclusive thing there, apart from they don't seem to be the same. So power supply rail positive to here. Okay. Negative there. What I've got? Well, that reads a fairly low reading. Now this is the polarity this would normally operate in, which suggests I should see open there, because that's saying that this voltage can't go above 0.82. Yeah, positive to here. That sees the same. Right, let's power this up again and let's have a look at the supply rails to these op amps. So I'll just get a connection to ground, switch on. Yeah, light bulb's doing the same thing. Let's see. So this is positive. No, negative is minus 12. Positive I can easily check on this one actually, because it's here. That goes to this capacitor. Plus 12. So we have the supply rails as you would expect. They're normal. But even so, switch on again. Yeah, I mean, they're lighting up like fairy lights on Christmas Day, yeah. So there's definitely something wrong with these. Supply rails are okay. No shorts on the outputs that I can see. There's something else that lights up quite brightly further back, actually. Over there, but that's only 37 degrees. There's something here that's 30 odd degrees. These things are obviously too hot. Yeah, pushing towards 50 degrees again. Yeah, 49. Okay, so supply rails are good. Nothing shorting on the outputs. They're all high resistance, so even if one of these was being driven quite hard, it wouldn't be driving much current out of the output because the loads are high resistance. Which pretty much brings me to the fact that I'm going to have to change these. It's obvious now, just referring back to the old video, that one of these at least was getting hot before anyway. This thing is now running cold when it was definitely running hot also. Unfortunately, I don't have these in stock either, but I'm sure I can find them quite cheaply on AliExpress. And the postage is pretty quick at the moment, so it shouldn't take too long to get here. Let's order a pack of 10 or something, so we've got quite a few to go at. And then if push comes to shove, I'm going to have to reverse engineer all this up to see if I can figure out what's wrong with it. But from what I've seen so far, it looks like it probably is these chips, and whatever damaged this in the first place, which runs from the same supply voltage, by the way, as those do, the 35 volt, then yeah, maybe that's where it's all gone horribly wrong. Okay, while we're waiting for the parts for this to arrive, because I mean those op amps are definitely getting hot, and I don't think they should do at all. Also, as I showed you on the previous video, at least one of those was also getting hot as well. I just hadn't noticed it the first time round. But what I did notice is that when I was looking for a ground previously, I had a connection from the heatsink to the ground, you know, the black lead, which is a sense tap on the transformer, and now I don't. And the reason is that if you look here, this socket with these wires is clearly not the original one, and there, where the screw is coming through, is actually catching on the PCB. I'll put it in the hole there, so it's actually scraping against the PCB, and that track which it's cut into a bit, that is ground. So that does connect to the black lead, the sense tap on the transformer, that is ground. And when this was bolted on with the screw coming through, that was then connecting the metalwork of this to the 0 volts, yeah, on the transformer, the center tap. And also this metalwork is connected to ground. We have these earth leads on it, okay. So what that meant is that I had a connection from here to here, and now I don't. But I don't think that is anything to do with the problem that we have with this now. I honestly don't know if this was in protect mode before I changed that chip. and I didn't actually ever connect it to the light bulb, so it may well have been drawing, you know, some power. In fact, all this area was getting hot, so it must have been. I just didn't have that connected. That's a bit of glue on there, by the way. Just looking to see what it was. You can see it on here as well. We know that this chip isn't connected to this chassis at all. There's this heatsink, which was then connected to ground. And also bear in mind, I have an isolation transformer on my bench. So this metal plate, this earth wire is not earthed. I have isolation on my bench. So although I'm connecting this earth to the 0 volts, which is probably where you'd expect it to go, but it in fact doesn't. There is no connection to earth on my bench, so that isn't a factor either. Just interested to see, because of what happened, if I go onto the metal of here and just connect across all the pins of these devices. I hit the metal with it, and that's why you hear this. Again, I hit something else. Again, I keep hitting the metal with it, guys, that's what it is. Okay, so none of those pins on those devices connect to that. So the fact that effectively this heatsink was connected, in fact you can see the tag on it, the earth, yeah, the fact that was connected to this point, I don't think would honestly make any difference whatsoever, especially seeing as this is floating on my bench. Okay, so that's the first thing I noticed. Now, what I didn't realise, and I've realised since, that this screw has been cut off with a hacksaw. So when I first had this must have been in the bottom position to stop that happening, okay? So if I put this back in using this screw at the bottom, okay, this one at the top. So this is what I just didn't realise. And I power this up, okay, with the light bulb still in series. Let's see. So the light bulb comes on and then goes dim, but it is still on, and we still have the protect mode. In fact, oh, the power light's a little bit iffy. Look at that. That's just a bad connection somewhere. Yeah, it's just a dodgy connection on the power LED. So the problem still persists, and if we just flip this over again and back to here, these are still really getting hot. Okay. So what I'm thinking is, I've changed this chip. It's a new one. Could it be a fake one from AliExpress? I really have no idea. Is there any way we can easily test to see how much current is flowing through that? Because it's bolted to the heatsink, maybe it wouldn't warm up particularly. I mean, it was glowing before, fair enough. And the same applies. Can we measure how much current is flowing into these op amps? And I think we can. And I think that's the topic for another video, because this is a different fault finding technique, which I think we should talk about in isolation to this job. Okay, so there you go, guys. That's where we are so far. Hope you enjoyed that. I'll order the chips anyway, even if these turn out to not be faulty. I may as well. If nothing else, will be useful spares, and if I do need them, well, at least they're already on the way. And we can continue exploring this one a little bit more. Okay, guys, I look forward to seeing you all again soon on Learning Electronics Repair. Ciao for now.